Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at two-dimensional vectors. So you might wonder if you can create a vector with two or more dimensions, just like you can create a primitive array with two or more dimensions. And the answer is yes, of course you can, although the syntax is a little bit complicated. So we'll take a look at this in this tutorial at two-dimensional vectors, but you can create them with more dimensions. So I've included vector in here under standard namespace. Let's create a vector we'll decide what of in a minute, but I'm going to call it grid. So let's imagine that we want a grid of numbers, let's say a grid of integers. We can represent that using a two-dimensional vector. So what we want here is in the type of the thing that we're going to put in this vector is not going to be the integer directly. We're actually going to put other vectors in this vector. So we're going to have a vector of vectors. So let's type here vector, and this is going to be a vector of int. So we can think of this vector as the outer vector as containing the rows of our grid, and this vector is a particular row in the grid. So now we've got a whole grid using a two-dimensional vector, and we can pre-size this if we want to. Let's suppose we want a grid with, say, 3 rows and 4 columns. We can supply arguments to the constructor here. So if we want maybe 3 rows, then we want to tell this outer vector here that we're going to have 3 rows, and each row is itself a vector. So we can say here 3 rows, and we can initialize each of those rows with a vector of ints, and we can pre-size that vector as well if we want to. So I'm going to pre-size each row to have 4 columns like this. Furthermore, if I want, I can initialize each value in every cell of this grid with a value. So I can initialize the values, the elements in all of these rows to some value. Most commonly you'd want to use naught here. So it's the rows that actually contain the integers, and that's why this takes this argument here. Remember it's the columns that contain, it is the rows that contain the integers. So that's why I'm using the constructor of this vector here. This vector here, it contains the rows. It contains the rows which contain the integers, if you see what I mean. And that's why we have to initialize this with a vector. So normally you want to initialize the elements in a row to 0, but let's initialize it to 7, just so we can see clearly what's happening here. Now you have to put, at least on my compiler, and it's probably the same for all of them, you have to put spaces here. Now I've got a vague memory of, in the past, writing vectors like this without any spaces, but even my memory's playing tricks on me, or else that's just changed, or else it doesn't work on this compiler. And in any case, I think the best practice is to put spaces here, because it just makes it much easier to read. So we can iterate through this vector using a 2D array. So let's say here for int, and we'll iterate first through the rows, and then for each row we'll iterate through the columns. Let's say for int row equals 0, row less than grid dot size, row plus plus, and then for int col equals 0, col less than grid, and now let's use the row index to get a particular row like this. So we'll iterate col over the size of the row, the number of elements in the row, like this. And then we will let's output here grid, and we can use two kind of array index type operators like this to access the rows and the columns. So the first index here is going to be a row. That's like the index here into this outer vector here. And then once we've got the row out of the outer vector, that is itself a vector which contains all the elements in that particular column. So this bit here is a vector, and we can then use this to access the elements in that particular row using this column. It's a bit confusing that we have to access the elements in a row using something called col, but that's just how it is if you think about it. The elements in a particular row are the columns. Now let's just flush the output there, and finally after every row we'll output a new line to give us kind of neat presentation of this. So if we run this now, here is our grid of 3 rows and 4 columns. And of course you can have, by the way, these warnings here, they're just bugs in Eclipse. You can see that the program compiles without any errors or warnings. So these are purely bugs in Eclipse, which I'm going to ignore. You can have, of course, what we call a ragged array. You can have the rows don't all have to be at the same size, because of course the rows are resizable. For example, we could do this. We could say grid, and let's take the second row, which is at index 1, and let's do push back, and let's put a 8 on there. So now our loop can still handle this. Again, we've got an annoying warning in Eclipse, but if we build the project, we see that there are no errors or warnings in there. It's actually fine. And if I run this, we can see that we've got one row now that's longer than the others. So you don't have to have them all the same size as you would do with an array. So if you want to practice this, I'd suggest create a 2D vector, pre-initialize the size of it, and then fill it with the 12 times table, and then print it out, display it, and see how you get on with that. So I'll leave that as an exercise for you if you want. And until next time, happy coding.